In this video, we're going to talk about blueprint reading basics. Now this is a potentially huge topic, so we're just going to cover some basics. Among the topics we'll cover are how to read a blueprint or drawing, how to read a drawing format, how to identify drawing views, first angle versus third angle projection, how to read and interpret dimensions, and how to read and interpret tolerances. Now the term blueprint doesn't really apply anymore. It comes from an old method that was used prior to computers and laser printers to produce prints for a machine shop. But this term is still used, as well as print for short, or more commonly, just drawing. Drawing is the term we'll be using in this video. Now a drawing is the method we use to tell a machinist or a programmer how to make a part, what's critical about it, the material you need to make it, and many other pieces of information. We'll start with the drawing format and the title block. The first thing you'll notice is that the drawing format is divided into zones, A, B, C, etc. along the bottom, 1, 2, 3, 4, and so on along the side. These zones are used so you can quickly find a specific dimension. For example, this dimension, 10.84, is in zone J2. Now at bottom right, you'll typically see your company name, although if you're working in a job shop, you may see the name of the company you're doing work for instead. Here you find the part number of whatever you are making, the revision level, more on that later, and here you see the person that approved the drawing before it was released to the shop. Down here, you see the drawing size and scale. Now in today's world of CAD systems, these don't mean as much, but it used to be that a designer would draw a part to scale. In this case, this was drawn at quarter scale, meaning it is drawn at 1/4 size of the actual finished part. Size here refers to the size of the paper the drawing is created on. A size is 8.5 by 11, B 11 by 17, C 17 by 22, and so on. Again, in this day of computers, it's usually not relevant. You'll usually just print out whatever size you need to be able to see all the dimensions on the print. Also in this area, you will find a space for both a material and a finish callout. Off to the left side of the title block, there is the tolerance block. We'll come back to that a little later. At the bottom left, you'll find a section for notes. Nearly anything can be here. Often you will find the material, as well as any note that applies to the entire drawing. Now this area here at the top right is very important. I referred to the drawing revision earlier. This is called a revision block. Each time a change is made to the drawing, whether it's a minor note change or a major redesign of the part, the drawing gets a new revision letter. A drawing starts with no revision, and for every change, we bump the letter up one. A description of the revision is found here, as well as the zone the change can be found in, and who made and approved the change. It's critical that you as the machine operator can identify the revision level on the drawing and make sure the program in the machine matches. In this case, the program in the machine should be revision A to match the drawing. Now this is something your supervisor or the setup machinist should have checked, but you need to be aware that it's very important. You don't want to find out too late that you've made a part to an outdated print. Now let's talk about drawing views. There are two different ways that views are displayed on a drawing. They are either third angle projection or first angle projection. In this graphic, we've divided the screen into two sections to represent the two types of projection. The top of the part is highlighted in blue, and it's shown here in the center of the drawing. This angle is the same as looking down on the physical part. As we rotate the part up and to the left, we see the left side. It's highlighted here in red. Looking at the split screen, we can start to see the differences between first angle and third angle projection. The left side of the part is shown here on the left side of the drawing in third angle projection, but it's shown on the right side of the drawing in first angle projection. Now it's the same physical side of the part, it's just shown in a different place on the drawing. Now rotate the part up and to the right, and we see the right side of the part, highlighted here in green. Notice again on the split screen that the right side of the part goes here on the third angle drawing and here on the first angle drawing. Again, these sides always reference the same physical side of the part, The difference between third angle and first angle projection is simply the way they are laid out on the drawing. In the US, third angle is the most commonly used, and that's what we see on this drawing. But you need to check your drawing to be sure. Some industries, like the automotive industry for example, will use first angle projection even in the US. If your drawing doesn't tell you and you're not sure, ask your supervisor. This is what is called a section view. The dashed line here means that we are looking at the part wherever that line crosses the part. And these arrows here define the direction we are looking in from. Imagine it as if the part has been cut in half and you turn it to look at the cut edge. This view is often helpful or even necessary to show details of the part you wouldn't otherwise see, like the depth of this pocket and this radius. This is what we call a detail view. This is commonly used to show a feature that is too small, or maybe there are too many dimensions to be seen well in a regular drawing view. For the detail of this slot, for example, we use detail A, and this view gives all the dimensions that are required. Okay, now let's get into dimensions. Each number you see on this drawing is called a dimension. In this case, we're looking at dimension in inches, but everything we talk about in this video also applies if you're looking at metric numbers. Here you will find numbers that represent the overall size of the part as well as its thickness. Now these lines are called liters, and as you can see, they let you know that this dimension is referring to this edge or whatever the feature might be. In the case of this part, we see that the drawing tells us that it is 15.50 inches wide, 7.00 inches tall, and 0.75 inches thick. In this case, the liter is pointing at the center of a hole, so we know that these holes are 0.50 inches from the edge of the part, and this second set of holes is 5.25 inches from the first set of holes. Now while we're talking about holes, this is a typical call out for a hole or multiple holes. The 4x means that this call out is going to be true for 4 holes. Through means the hole is going to go all the way through the part. And this means that the size of the hole is 0.516 inches in diameter. Now if the hole is threaded or tapped, you will see a call out that looks like this. Here the drawing says that there are to be 6 holes, the thread is 1/4 and each thread is to go 0.50 inches deep. You've probably noticed a number of symbols that are most likely unfamiliar to you. This one here represents diameter, this one represents depth, and that's all we're going to cover right now. Now we're going to do a quick overview of tolerances. A tolerance tells us the amount and the direction that a feature can deviate from a dimension on the drawing. We'll explain more in a few seconds. As we talked about dimensions, you probably noticed that the dimensions on this drawing don't all have the same number of digits. What you're seeing is the way that we communicate how critical a dimension is. So here, for example, we have just 2 numbers to the right side of the decimal place. But here, we have 3 numbers to the right side of the decimal place. Now, generally speaking, the more numbers there are to the right of the decimal place, the more critical that dimension is. 1 number, not too critical. 2 numbers, more critical. And 3 or even 4 numbers means very critical. Remember earlier, we talked about the tolerance block. This is how you decode the actual tolerance required. Now, most shops will have a standardized tolerance block that is consistently used on every drawing. In this case, a single number after the decimal means this feature needs to be within plus or minus 60 thousandths, or 0.060. 2 decimal places, plus or minus 20 thousandths, 0.020. For 3 decimal places, plus or minus 5 thousandths, 0.005. And we don't have it on this drawing, but if you see 4 decimal places, it usually means plus or minus 1/10 thousandths of an inch, or 0.0001. Other videos in this series will give you a better understanding of what unit of measurement we are referring to when we say 5 thousandths, 20 thousandths, etc. Now let's go even deeper so you can visualize these tolerances. We know that more digits after the decimal point means the feature needs to be held to a tighter or more accurate tolerance. This dimension says this hole needs to be 2.250 inches from this other hole. Because it's a 3-place decimal, we know that this feature must be 2.250 from this hole, plus or minus 5 thousandths. We always shoot for perfection, of course, but the tolerance means that this hole doesn't need to be at exactly 2.250, but can float, if you will, 5 thousandths in this direction or 5 thousandths in this direction, and still be considered good. Think of this as a range or a window that this hole must fall within. When the finished part meets this requirement and falls within this range, we say that the feature is in print. This same idea holds true when we look at the tolerance of a hole or any other feature of the part. This board that reads 4.00 through has a looser tolerance. In this case, based on the tolerance block, this 2-place decimal means plus or minus 20 thousandths. So this hole can be anywhere between 3.98 inches and 4.02 inches and still be considered in tolerance or in print. Whatever the tolerance is, you still need to have the correct program, the proper tooling, and a solid setup in the machine in order to make good parts. And all of that starts with a good understanding of the drawing. So let's do a quick summary. In this video, we covered blueprint formats, drawing views, including section and detail views, the difference between first angle and third angle projection, and we covered how to read and interpret both dimensions and tolerances. So that's a 10,000 foot view of blueprint reading, plus or minus 1,000 feet. Thanks for watching.